Good day, student. You are welcome to this STA 131 class. Today, we are considering measure of dispersion or measure of spread. And by the grace of God, under this particular section, we are going to consider variance, standard deviation, and coefficients of variation. Those are the three major measures of spread or dispersion that we are going to consider in this particular class. So, first of all, we want to look at the ungrouped data. The variance for ungrouped data, there's something called population variance, and we also have sample variance. For the population variance, we denote it with sigma square. Sigma square. You can see the sign there, sigma square. And the formula is summation SI minus S bar, everything square, divided by N. That N is the number of observations under consideration. Or, if you want to put it in a better form, you can simplify it further by saying the sum of SI square minus N S bar square. Then everything divided by N. We are going to achieve the same thing. Then, and for the sample variance, the only difference is just the denominator. The denominator for sample variance will be N minus 1 instead of the whole N. You have to deduct 1 from the number of observation before. That's just the difference between population variance and the sample variance. For the population variance, we divide the whole thing by N, but for the sample variance, we divide the whole thing by N minus 1. Now, to illustrate this, let's consider the following examples. We are to obtain the variance of the following raw score on the student of AEF 204 continuous assessment. So, their assessment is over 30. So, the first person scored 23, another person scored 23, another person 11, 04, 07, 28, and then 24. So, to obtain the variance, we need some information. So, we need the sum of x, that is 120. That is where you sum everything. 23 plus 23 plus 11 plus 4 plus 7 plus 28 plus 24 will give us everything, will give us 120. The number of students there, they are just 7. That is n. Then, when you square each of these values, 23 square, the next 23 square, 11, you square it, 4 square, 7 square, 28 square, 24 square, and you sum everything, that will give us 2604. Now, for the population, as I've said, the difference is just the denominator. So, for the population variance, we have the sigma square, which is the sum of SI minus S bar, everything square, divided by N. So, and that S bar, we have to calculate it, which is the mean from ungrouped data. That is sum of SI divided by N. And that will give us 23 plus 23 plus 11 plus 4 plus 7 plus 28 plus 24, everything divided by 7. And that will give us 120 divided by 7, which is 17.14. Therefore, for the variance, we now have this. That is sigma square, which is sum of SI minus S bar, everything square. So, the mean there, that is 17.14. So, that is what we are now going to insert inside. So, we are going to have, since 23 appear twice, so we are going to have 2 multiplied by that 23 minus 17.14 square, plus the next one, which is 11. 11 minus 17.14 square, plus the next one, which is 4. 4 minus 17.14 square, plus 7 minus 17.14 square, plus 28 minus 17.14 square, plus the last one, which is 24 minus 17.14 square. So by the time you simplify it further, we are going to have the total to be 546.85716. So since we are talking of population variance, so we have to divide that one by 7, which is the total number of students. The total number of students involved in this particular continuous assessment, they are just 7. So we have to divide it by the whole 7. And that will give us 78.125. So using the other formula the other formula, the summary formula. Already we have obtained the sum of s, and we are also obtained the sum of s square. So by the time you slot it in, that will now be sum of s square minus ns bar, everything divided by n. And that will now be 2604 minus 7 into 17.14 square divided by 7. By the time you simplify that one further, you are still going to obtain the same thing, which is 78.204, which is the same thing we obtain when you use the deviation method. This is a sample variance. For the sample variance now, as I've said, for the sample variance, the only difference is just the denominator. Rather than dividing it by ordinary n, you are going to divide it by n minus 1. So, students, you have to take note of that. Anytime they ask you, obtain the variance, if it is not specified, you have to give us the two, both the population and the sample variance. But at times, we may specify with the sign. The moment you see s square, s for solar, square, then they are talking of what? They are talking of sample variance. But the moment you see that sigma square, they are talking of the population variance. We don't need to put whether population or sample. The moment we put that sign, you should know which one we are asking for. So you should take note of that. Since our S bar is 17.14, so the sample variance, which is s square, will just be sum of si minus 7, that's 17.14 square divided by n minus 1. Since we have done the upper one before, that is just 546.85716. Rather than dividing it by 7 as we did under population variance, we are now going to divide it by 6. And that will give us 91.14286. And we revert to that as the sample variance. So we can as well use the formula method for this one also. Let's look at the formula method. The formula method, that is sum of s square minus ns bar square, everything divided by n minus 1. By the time you do that, you have 2604 minus 7 into 17.14 square, everything divided by 6. That will give us 91.2571, which is the same thing we obtain when we use the deviation method. That is for both the population and the sample variance. So for better appreciation, maybe we should take one more example. Example 2, we have to obtain the variance of the following raw data on student monthly allowance. Monthly allowance. Students, what they obtain, that is what their parents normally give them on monthly basis. So we sample among the students. One of them said 24,000. One say 8,000. Another person say 18,000. Another person say 19,000. Another person say 12,000. So we want to obtain the variance. To obtain the variance, we start with the population variance. As I have said, just divide the whole thing by what? By n, without removing anyone. So we first of all obtain the mean. The mean give us 16,200. That is the average allowance obtained by students. The average allowance obtained by the student is 16,200. Therefore, the variance now, as you all know, for the population, that's a sigma square. That will be sum of SI minus, that's 16,200 all square divided by 5. Since we have 5 of them, 5 students involved. So by the time you do that, we now have the population variance. We have it to be 3136000. Now, for the same set of students, we want to obtain the sample variance. So that will now give us the mean, as you have already known, is 16,200. That is the average monthly income by the student. So to obtain the population, the sample variance now, so we only need to do is to deduct 1 from our n. Our n is 5. By the time you take away 1, that will give us 4. So you just divide the upper one by 4, and that will give us 3920000. So that is the end of that both the population and the sample variance. So the next thing, we move to the standard deviation. For the standard deviation, we have both the population and the sample standard deviation. For the population standard deviation, we have just sigma, which is equal to the square root of the sum of SI minus S bar, everything square, divided by n. Then, while that of sample standard deviation is just S for solar. S is equal to the square root of the sum of SI minus S bar, square divided by n minus 1. So now we want to illustrate with example. You have to obtain the standard deviation of the following raw data on student score in AEF 204 continuous assessment. So 23, 23, 11, 11, 04, 07, 28, 24. So just as we did under variance. So standard deviation by definition is just the square root of the variance. Standard deviation is just the square root of the variance. So we are now taking the square root down, the square root of the variance. So by so doing, what we have obtained before, we have obtained variance to be 78.1225. That is what population variance. So by the time you now take the square root of it will now be 8.8387. The square root of that population variance will now be 8.8387. So now let's look at the sample standard deviation. The sample standard deviation, as I've said, is S. S for solar is the square root of sum of SI minus S bar, everything squared divided by n minus 1. Our S bar, as I've said, is 17.14. So as I've said before, the sample standard deviation is just the square root of the sample variance. When you take the square root of the population variance that we have obtained before, our population variance was 91.14286. By the time you now take the square root, we are now going to have 9.5469. So let's take another example for better appreciation. You have to obtain the standard deviation of the following raw data on student hostel distance from the university library in meters. Student hostel distance from the university library in meters. Some of them walk 604 meters before they get to the library from their hostel. Some 407, some 208, some 318, some 321, some 822. So we want to obtain the standard deviation. To do that, we are starting with the population standard deviation. As I've said, the population standard deviation is just the square root of the population variance. So to do that, first of all, obtain the mean. The mean distance of the student from their various hostel to the library is 446.6667 meters. That is the average, on average. That is it. So therefore, the standard deviation will now be the square root of sum of SI minus this 446.6667 square divided by 6, since we are talking of population standard deviation. So by the time you take the square root of that, we are now going to have this. The variance is 42751.892. So by the time you take the square root of it, we are going to have 206.7653. 206.7653. That is for population. Now let's look at the sample. For the sample, as I've said, the sample, the only difference is just you need to deduct 1 from our n, from the denominator. So our denominator is just 6 of them. You know, we have six students concerned. So you deduct 1. Rather than dividing by 6, you are now going to divide it by 5. That's just the difference. So the sample variance was 51302.27. So by the time you now take the square root to obtain the sample standard deviation, we are now going to have 226.500. So that is the end of this standard deviation. The next measure that we are going to consider is what I refer to as coefficients of variation. The coefficient of variation is used for comparison. If you want to determine, you want to consider 2 different populations, and you want to know which of them is better or which one is more consistent, we make use of coefficients of variation. We use coefficients of variation to determine which population or which sample is more consistent than the other. It's for comparison. The major 2 for comparison is coefficients of variation. So let's now look at the formula. This is the formula. CV, coefficient of variation. That is the standard deviation divided by the mean. Then you multiply it by 100. At times, you may even remove the 100 so that your result will be in proportion. your result will now be in proportion, because we know that the standard deviation will definitely be below the mean. That is it. Where our SD is the standard deviation, the S bar there is the mean. So now to illustrate this, let's take example. We have to obtain the coefficient of variation of the following raw data on student score in AEF 204 continuous assessment 23, 23, 11, 04, 07, 28, 24. This particular one, before we have obtained the mean, and the variance, as well as the standard deviation. So the mean was 17.14, while the population standard deviation was 8.8387. So now the coefficient of variation for the population is now going to be 8.8387 divided by 17.14 multiplied by 100. That will give us 51.57%. 51.57%. Also, let's consider that of sample. We are now going to take the sample standard deviation, which was 9.5469. 9.5469. So we use that, we divide that with the mean, which is 17.14, and multiply by 100. And that will give us 55.70%. 55.70%. So that is that. Now let's take another example for better appreciation. You have to obtain the coefficient of variation for the following raw data on student monthly allowance: 24,000, 8,000, 18,000, 19,000, 12,000, and so on. So what we need for the population, we need standard deviation as well as the mean. So for that of population, the CV, that is the standard deviation for the population, which it was calculated to be 5,600, and the mean was 16,200. 16,200. That is the average monthly allowance for the student. You have multiplied that one by 100. We have 34.57%. Now let's consider that of sample. For the sample's coefficient of variation, so we are going to have the standard deviation, sample standard deviation divided by the mean. The sample standard deviation was 6260.9904. Everything divided by 16,200 multiplied by 100. That gave us 38.65%. So, students, we have come to the end of this particular unit. I wish you best of luck in your future classes. Thank you.